tabulated data. So here is a problem, and the best way to explain is through a problem. So the pressure P and the corresponding displacement are given in the table below. If the cross-sectional area is 0.5 square, then compute the work done. So this is like a calculation you might do when you are looking at work done in a piston cylinder system, where you have a displacement of the piston, and you basically have some tabulated data. So you can see here that the data at different displacements is given. The problem is that you're not allowed to choose X. It's been given to you. You'll see that the grid is not uniform. So we have 0, 0.1, then 0. So 0, 0.1, 0.2 is all grid size of 0.1. Then it goes from 0.2 to 0.4, it jumps by 0.2. Then it again goes increment of 0.1, and then it jumps by 0.3. And then 0.8 to 0.9 is just 0.1, and then again 0.1. So we see that the grid is not uniform. And all these formulas we used in the past for Simpson's rule assumed that the grid was uniform. So where was it? Here. You see this grid? This was the same grid. So that's going to be a problem. You know what? I did a mistake here. This grid should be. Yeah, this is not right. It should be between these points, delta x. I'll fix it later. This is not right. It should be delta x all over the place. Okay. So in a situation like this, what you want to do is you want to use different rules in different places. So whenever you see there's an opportunity to use Simpson's 3/8 rule, you want to use that because Simpson's 3/8 is more accurate than Simpson's 1/3, which is more accurate than Simpson's trapezoidal and rectangular. So whenever you can, you need to check if 3 points have, if there are 4 points, and those 4 points, well, if you see if you can find a multiple of 3 first, and if it's a multiple of 3, then you can use the first rule, the Simpson's 3/8 rule, the more accurate one. And if you can't find that, then you shift to 1/3, which means n should be even. And if not, then you go to trapezoid and so on. So in this case, what we can do is we can actually try to see what rules we'll be using for different ranges. So first, we see that we have a grid of 0.1, 0.1, but it changes here. So we could perhaps integrate these 3 using one integration, right? And since there are 3 points, you cannot use the 3/8 rule because you need 4 points. So you're stuck with either Simpson's 1/3, trapezoidal, or rectangular. Always choose a more accurate representation. So we'll use Simpson's 1/3 here. Okay, next we need to look at, we need to integrate from 0.2 to something. So 0.2 to 0.4, 0.4 to 0.5. Now we can go from 0.2 to 0.4, but we can't go all the way to 0.5 because the grid changes from 0.5 to 0.4 to 0.5, it's only 0.1. So we need to use, integrate just to these points with, so there are 2 points. And remember, in 2 points, you cannot pass Simpson's 1/3 rule. You need to use either trapezoidal or rectangular, but trapezoidal is more accurate. So we'll stick with trapezoidal here. Okay, next we go from 0.4 to 0.5. Again, we notice that you just have 2 points because after that, the grid changes non-uniformly. So here we'll also have to use trapezoidal. Next, we'll look at 0.5, 0.8. Again, looks like you need to use trapezoidal, right? Then we have 0.8, 0.91, which is good. We have 3 points, and 3 points we can use Simpson's 1/3 rule. So we'll take the last bit and then use Simpson's 1/3. Okay, so that's like the key thing. Once you identify what those, what you're going to use, you can now start writing a formula. So here we have I would be I 1/3. So I 1/3 will be, so Simpson's 1/3 rule. So delta x, so 0.1 divided by 3. The values at these points, so 4 plus the formula here, if you see the formula for the 1/3 rule. We just need, in this case, this formula, 141. So 4 times 4.23 plus 4.53. So that completes the first part. Next, we have to use the trapezoidal rule, which says that is point. So the grid size is 0.2. So 0.4 minus 0.2 is 0.2 divided by 2. And then we need to get the height. So the sum of the height. So 5.3, so 4.53 plus 5.34.
Question.
Yeah.
Why the 1/3 rule for one section, but then the trap for the other sections?
Because we have 3 points, 0.0, 0.1, 0.2 here. And they have the grid size is uniform, it's 0.1. But when you jump from 0.2 to 0.4, the grid size here is 0.4 minus 0.2 is 0.2, which is not the same as, okay?
And so instead of dividing them by 3, divide them by 2.
Yeah, because if you look at the trapezoidal rule here, the formula is here, I think.
Yeah, so.
It's half F0 plus Fn. Okay, so let's complete this. Then we have the next part. So now we have 2 grid points. They're spaced. Spacing is 0.1 between 0.4 and 0.5. So 0.1 divided by 2. And then I need to get the height. So that would be 5.34 plus 5.88. Then I use the trapezoidal rule. So 0.1 divided by 3. Sorry, my bad. So 0.8 minus 0.5, let me write it down explicitly, times 5.88 plus 8.03. And then the last one is 1/3 rule. So here the grid spacing is 0.9 minus 0.8 is 0.1, and 1 minus 0.9 is 0.1. So 0.1 divided by 3 for the 1/3 rule. And then I need to do first point, 8.03, 4 times the second point, 8.96, and 1 times the third point, which is 10.0. Okay, so the final answer, which is basically taking all this and summing it up, I comes out to be 3.1393. That's the final answer.